Morning to all. Myself Cyberco, second year BTech in Mechanical Engineering. Today my topic is vapor compression cycle. Introduction to vapor compression cycle. The vapor compression cycle is a fundamental refrigerator cycle. It is widely used in refrigerator and air conditioning systems. Understanding this cycle is essential for studying thermodynamics and heat transfer. Basic principles. The cycles operates on the principles of thermodynamics and phase changes. It involves the compression and expansion of a refrigerator. The cycle consists of four main processes: compression, condensation, expansion, and evaporation. Components of the cycle. There are four primary components: compressor, condenser, expansion valve, and evaporator. Each component plays a vital role in the refrigerator process. Through these parts facilitate the continuous circulation of the refrigerant. Refrigerant overview. Refrigerants are substances used to absorb and transfer heat in the cycle. Common refrigerants include R31A, R410A, and ammonia. The choice of refrigerant affects efficiency, safety, and environmental impact. The compressor. The compressor raises the pressure and temperature of the refrigerator vapor. It is often powered by an electric motor or a gas engine. By compressing the refrigerant, it prepares it for condensation. The condenser. The condenser cools the high pressure refrigerator vapor, converting it to liquid. Heat is released released to the surroundings during this process. The efficiency of the condenser significantly impacts the overall cycle performance. Single refrigerant cycle. The expansion valve. The expansion valve reduces the pressure of the refrigerator liquid before it enters the evaporator. This process leads to a drop in temperature, preparing the refrigerant for evaporation. The valve regulates the flow and maintains the desired pressure difference. How thermoplastic expansion valves work: condenser to thermostatic, expansion valve, evaporator to compressor. The evaporator is where the refrigerant absorbs heat from the environment. The low pressure refrigerant evaporates, changing from liquid to vapor. The process provides the cooling effect in refrigerator and air conditioning system. Cycle process overview. The vapor compression cycle consists of four main processes in a closed loop. It begins with vapor compression and ends with vaporization. Each stage is crucial for efficient heat transfer and cooling. First process, compression. In the compression press, the refrigerant vapor is compressed, raising its pressure. The temperature of the vapor also increases significantly. The high pressure vapor then moves to the condenser. Second process, condensation. The high pressure vapor enters the condenser where it releases heat. As heat is released, the vapor condenses into a high pressure liquid. The press is essential for preparing the refrigerant for the expansion process. Condensation, forming IM bonds from gas to liquid. Condensation is exothermic because energy is released. Dynamic equilibrium. Rate of vaporization equals rate of condensation. Gas molecules about liquid becomes constant. Vapor presses. Third process, expansion. The high pressure liquid refrigerant flows through the expansion wall. Here it expands a pressure drop which reduces its temperature. This low pressure liquid is now ready to absorb heat in the evaporator. Fourth process, evaporation. In the evaporation, the low pressure refrigerant absorbs heat from the surrounding. This heat absorption causes the refrigerant to evaporate into a low pressure vapor. The cycle then restarts as this vapor returns to the compressor. Efficiency of the cycle. Efficiency of the vapor compression cycle. It is measured by the coefficient of performance COP. A higher coefficient of performance indicates a more efficient refrigerator system. Factors affecting efficiency including the type of refrigerant, component design and operating conditions. Applications of vapor compressing cycle. The vapor compressing cycle is used in refrigerators, air conditioners and heat pumps. It is essential for both residential and commercial cooling solution. The cycle also play a role in industrial refrigerator and food storage. Next, environmental impact. The use of certain refrigerants can contribute to global warming and ozone depletion. Regulations have been established to phase out harmful refrigerants. The industry is shifting towards more environmentally friendly options. Limitations of the cycle. The vapor compression cycle is not suitable for all cooling applications. Its efficiency can decrease at high ambient temperatures. The system also requires regular maintenance to ensure optimal performance. Cycle with dry saturated vapor after compression. Future trends in refrigerator. Innovations in refrigerants aim to reduce environmental impact and improve efficiency. Smart technology integration is enhancing system monitoring and control. Research continues into alternate cooling methods beyond traditional vapor compression. HVAC share over refrigerator. Summary of key points. The vapor compression cycle is a critical process in refrigerator and air conditioning. Understanding its components and processes is essential for optimal system design. Future developments aim to enhance efficiency and reduce environmental impact. Questions and discussion. Thank you for your attention to vapor compression cycle presentation. I welcome any questions or topics for discussion regarding this cycle. Let's explore further into any specific areas of interest you may have. Feel free to customize any part of this presentation as needed. The area under the curve for the process 4 to 1 represents the heat absorbed from the refrigerated space. Area under the curve 2 to 3 represent the heat rejected the surrounding. COP improves by 2.4 percentage for compressor if the evaporate consists of temperature is raised of condensing temperature is lower. Okay, thank you.